Right. Okay. So let's go to the next problem. Now we have done several problems in remainder theorem and factor theorem. Now let's write down this. I will do a small summary of this remainder theorem. Then we can go to the next question. Right. Now listen to this. So I will take a function fx. I will take a function fx, then divide that function by x minus a, right? Then I will divide this function by x minus a. So when I divide this function by x minus a, then the quotient is wx. Quotient is wx. Then I will take the remainder as r, right? Let's take the remainder as r. Now, if you write down the identity using this division, right? Using this division, we can write down fx equal to x minus a into wx plus r, right? Now we have done this in last video, in last session, but this is just a reminder of this small summary of this. So when fx is divided by x minus a, the quotient or the answer is wx and the remainder is r. So we can write down fx equal to x minus a into wx plus r, right? So when x equal to a, we can write down fa equal to r. So remainder r equal to fa, right? So this is the basic remainder theorem. Now using this, I will extend this remainder theorem to another level, right? Now write down this small question. Write down this question. Right. So we are using that basic theory part to solve this question. Now write down, find the remainder obtained. Find the remainder obtained when the polynomial function fx, is divided by x minus a into x minus b, right? So we are going to find the remainder when fx function is divided by x minus a into x minus b. So x minus a into x minus b, this is a quadratic equation, quadratic expression, right? There are two factors. If you multiply, we have x square term here, x term and a constant term. So this is a quadratic factor, right? So we are dividing this polynomial by a quadratic function, right? So I will write down the quotient as wx, then remainder. So remainder we can write down. We know that in previous lesson, we have showed that if the degree of this divisor, right? If the degree of this divisor is 2, then degree of the remainder is 2 minus 1. That is 1, right? So if the degree of this dividing function is n, then the degree of the remainder is n minus 1, right? So here we can write down remainder as ax plus b. Remainder is ax plus b, because if the degree is 2, that means it is a quadratic expression. So if the degree is 1, that means that is a linear expression. So this is a linear expression. Remainder is a linear expression. I will write down that as Rx. Right. So using this, I can write down the identity. Fx equal to x minus a into x minus b into wx plus the remainder ax plus b, right? Plus the remainder ax plus b. Now here we have two factors. When you substitute x equal to a, this factor will become, this term will become 0, right? And also if you substitute x equal to b, then also this term will equal to 0, right? So first I will take x equal to simple a. When x equal to a, if a will be equal to, so this part will become 0 plus a simple a plus b, right? So I can write down a capital A plus b equal to fa. This is number 1, right? And also I can write down when x equal to simple b, when x equal to simple b, fb equal to 0 plus a simple b plus b, right? Now ba plus capital B, this is equal to f simple b, fb. So this is number 2. Now I have two equations, simple A capital A plus b equal to fa. Second one, simple B capital A plus b equal to fb. There are two equations. So you can solve these equations, solve these two equations simultaneously. Then you can find capital A and capital B separately. Right, let's do that. Now, let's find the values of capital A and capital B. Right. So first I will take the first one, simple A into capital A plus B. This is equal to FA. This is number 1. Then second one, simple B capital A plus B. This is equal to FB. This is number 2. Right. So now you can subtract these two. You can subtract number 2 from number 1. Right. So if you subtract these two, capital B we cancel. Right. Then A capital A minus B capital A, that is equal to FA minus FB. Right. Then capital A is a common term, A minus B. So we can take out the common term, FA minus FB. Now capital A will be equal to FA minus FB over A minus B. Right. So I will take this as number 3. I will take that as number 3. Right. Now, right. So same way we can find the value of capital B. Right. So using this number 1 and number 2, I can find the value of capital B. Now capital A is equal to, we got that capital A is equal to FA minus FB over A minus B. Right. Now look at this. Number 1 means A capital A plus B. This is equal to FA. This is number 1. So I will multiply this whole expression by B, by simple B. Right. Then second one, B capital A plus B. This is equal to FB. This is equal to FB. This is the number 2, second equation. So I will multiply this whole equation by simple A. Right. Then if you multiply first one by B, then we will get A B capital A plus capital B equal to BFA. Right. Then if you multiply the second one by capital simple A, you will get AB capital A. Here you will get B capital B. Here you will get A capital B equal to A FB. Right. Now we can subtract the first equation from the second one. Then these two terms will cancel. B capital B minus A capital B will be equal to BFA minus AFB. Right. Now we can take capital B as a common factor. B minus A equal to BFA minus AFB. Right. Now you can take the B minus A factor to the other side. If BFA minus AFB over B minus A. Right. So this is the value of B. This is the value of B. So if you multiply both numerator and denominator by -1 by -1, if you multiply both numerator and denominator by -1, then this will become A FB minus BFA over A minus B. So this is the value of capital B. I will take this one as number 4. Right. Okay. Now we can write down the remainder using this capital A and B terms. Right. Okay. Right. Now look at this. So we know that remainder Rx remainder is equal to Ax plus B. Remainder is equal to Ax plus B. Right. So we have found the value of A. A is equal to Fa minus Fb over A minus B. This is the value of A into X plus value of B is equal to AFB minus BFA over A minus B. Right. So this is the remainder Rx. So you can write down the remainder using simple A, simple B, Fa and Fb. Right. Using these terms, we can find the remainder. Right. So this is actually a theory part. So in the question paper, you will get you can get a question like this. So you can practice this question. Right. Okay. Right. Now you can use this result. You can use this result to find the remainder of a given example. Right. So I will take an example. So I am using this result to find the remainder of a given example. Right. So I will take example. Now look at this. I will take an example. X to the power 3 minus 2x minus 1. Right. So this polynomial function is divided by x minus 1 into x minus 2. X minus 1 into x minus 2. So I will take the quotient as Wx and remainder as Rx. Now here this divisor is a quadratic function, right? So the degree of this part is degree of this one is 2. So the degree of the remainder will be 2 minus 1, that is 1. That means this is a linear expression, right? So the remainder is a linear expression. Now we can use our result, right? We can use our result to find the value. Now we know that in the given example we had something like this: fx divided by x minus a, x minus b, result is wx, remainder is ax plus b, and we have found the value of capital A and capital B. Now we can use this same theory part to find the remainder Rx of this example. So here x minus a, we have here x minus b. Here instead of simple a we have 1. Here instead of simple b we have 2. So we can write down a equal to 1, b equal to 2. Now we have to find the value of fa and fb. Right? So here a equal to 1, b equal to 2, and here this is the fx function. This is the fx function. So fx is equal to x to the power 3 minus 2x minus 1. That is the value of fx function. Now I'm going to find the value of fa. Fa is equal to, so here a is 1, fa equal to f1. So we can find the value of f1, substitute 1 here. If you substitute 1 here, this will become 1 to the power 3, that means 1. 2 into 1, that is 2 minus 1. Right? So answer is minus 2. FB also we can find the value, that is equal to F2. B is equal to. So we can substitute the we can substitute 2 here. So 2 to the power 3 minus 2 into 2, that is 4 minus 1. So 2 to the power 3 is 8. 8 minus 4 minus 1, that is equal to plus 3. That is equal to plus 3. Right? So now we can find the remainder. Right? So remainder Rx, remainder is equal to, we know that from the previous result, remainder is equal to Rx is equal to Fa minus Fb over A minus B into X plus AFB minus BFA over A minus B. So this is the previous result. Now I am going to use this previous result to find the remainder of this function. Right? So here Rx is equal to, we know that Fa we have found the value of Fa. Fa is minus 2, Fb is 3, A is 1, B is 2. Now substitute the values. Right? Substitute the values. So if you substitute the values, Fa means minus 2 minus 3 over 1 minus 2 into X plus AFB. A means 1, FB means 3 minus BFA. B means 2, FA means minus 2 over 1 minus 2. Right? Now write down the final answer. Here 2 minus 3 minus 1, that is 5. 5x plus, if you simplify this one, 3 plus 4 over minus 1, that is equal to minus 7. Right? So remainder is equal to, remainder will be equal to 5x minus 7. This is the value of Rx. So in the right, that way we can directly use the result we have got from the part 1 to find the value of this remainder Rx. Right? Okay. Now let's move to another question. Right? Let's do another question. Right. So I think you have understood this, right? So keep watching our videos, then you will get more knowledge about this lesson, and you can get higher results. Right. So I'm going to do the next question. Write down the next question. Write down let fx is a polynomial function. Write down let fx is a polynomial function of degree 3. Let fx is a polynomial function of degree 3. Right? Write down when fx is divided by, fx is divided by x plus 1, the remainder is minus 3. The remainder is minus 3. Right? Next, write down when fx is divided by, x plus 2, the remainder is plus 1. The remainder is positive 1. Next, write down and x minus 1 x minus 1 is a factor of fx, is a factor of fx, right? And also x minus 2 is a factor of fx, is a factor of fx, right? Okay. Now they have given that fx is a polynomial function. In this question, they have given that fx is a polynomial function of degree 3, right? Degree 3 means the maximum power of x is x to the power 3. So we can assume that fx is equal to, fx is equal to a x to the power 3, ax to the power 3 plus bx square plus cx plus p, right? So we can assume that fx is a polynomial function of degree 3. Then we can write down, we can assume this is the function of fx, ax to the power 3 plus bx square plus cx plus, right? Now here they have said that when fx is divided by x plus 1, the remainder is minus 3. So we can write down when fx is divided by x plus 1, we can write down quotient of the answer w1x, then remainder is minus 3, right? Remainder is minus 3. Then using this, we can write down the identity fx equal to x plus 1 into wx plus the remainder minus 3. So I will take this one as number 1, right? Now we can use this. So they have said that when fx polynomial is divided by x plus 1, the remainder is minus 3. So using that detail, we can write down this identity. Now when x equal to minus 1, f minus 1 will become, so when x equal to minus 1, this term will become 0. Then f minus 1 will become minus 3, right? F minus 1 will become minus 3, right? Then same way we can write down, they have said that in the second sentence, they have said that when fx is divided by x plus 2, the remainder is plus 1. So using the same method, we can write down the identity fx, right? When fx is divided by x plus 2, then we can write down x plus 2 into wx plus remainder is plus 1. So I will take this one as number 2, second equation, right? Second one. Now when x equal to minus 2, now look at this. When x equal to minus 2, f minus 2 will become, so minus 2 and plus 2 will become 0. This term will become 0. Now this is 1 plus 1, right? Now we have two expressions. First one is f minus 1 is equal to minus 3. Second one is f minus 2 equal to plus 1, right? Plus 1. Now same way we can write down the other two expressions, right? So they have given that when fx is divided by x plus 1, remainder is minus 3. When fx is divided by x plus 2, remainder is plus 1. And they have given that x minus 1 is a factor of fx. X minus 1 is a factor of fx. So what is the meaning of that? That means when you divide fx by x minus 1, right? This is the quotient, remainder is 0. Right? So using that, we can write down fx is equal to x minus 1 into wx plus 0, right? I will take this as number 3. So here also, when x equal to plus 1, when x equal to plus 1, we can write down f1 is equal to 0. So this is the third expression we got. This is the second one, right? And they have said that, and also x minus 2 is a factor of fx. So x minus 1 is a factor, then x minus 2 is also a factor. So we can write down fx is equal to x minus 2 into wx plus 0. Number 4. Now x minus 2. So when you substitute x equal to 2, when x equal to f2 is equal to 0. So this is the fourth expression, right? That is the fourth expression. Now using these four, we can find the value of a, b, and c, d, right? We can find the value of a, b, and c, d, right? Now let's find that. Let's find the values, right? So now look at this. Now here we know that fx is equal to, we have taken that fx is equal to ax to the power 3 plus bx square plus dx plus cx plus d, right? This is fx. So when x equal to minus 1, when x equal to minus 1, we can write down f minus 1, right? F minus 1, when x equal to minus 1, f minus 1, that is equal to, so substitute minus 1 here, minus 1 to the power 3, that is minus a here plus b minus c plus d. This will become minus 3. So from the first expression, we know that f minus 1 equal to minus 3, and we can find the value of f minus 1 using this expression, using this function. So f minus 1 equal to minus 3, and also f minus 1 equal to minus a plus b minus c plus d, right? So I will take this as number 5. Take this as number 5. Then when x equal to minus 2, when x equal to minus 2, again we can write down f minus 2, right? That is equal to, when you substitute minus 2 here, minus 8a plus 4b minus 2c plus d, right? That is equal to plus 1. I will take the test number 6. Sixth one. Then when x equal to 1, when x equal to 1, we know that f1 is equal to 0. We have found the value. So substitute here 1. A plus b plus c plus d, that is equal to 0. Number 7, right? Number 7. When x equal to, when x equal to f2, that is equal to, substitute 2 here, 2 to the power 3, that is 8. 8a plus 4b plus 2c plus d, that is equal to 0. This is number 8, right? This is number 8. Now using these 4 equations, we can solve these 4 equations as simultaneous equations, right? We can solve these equations as simultaneous equations. Then we can find the value of a, b, and c, d, right? Because there are 4 unknowns, and there are 4 unknowns, a, b, c, d, and there are 4 equations. So using these 4 equations, we can find the value of a, b, and c, d, right? Now I will take number 5 and number 7 equations, right? So let's find the values of these. Let's find the values of these. So I will take the number 5 and number 7. Now look at this. Number 7, that is equal to a plus b plus c plus d, that is equal to 0. So number 5, that is equal to minus a plus b minus c plus d, that is equal to minus 3. So we can add these two. If you add these two, a and a will cancel, c and minus c will cancel. So 2b plus 2d is equal to minus 3. Right? I will take this one as number 9. Right? Number 9. Then I will take number 8 equation, that is 8a plus 4b plus 2c plus d, that is equal to 0. And number 6th equation, that is minus 8a plus 4b minus 2c plus d, that is equal to plus 1. So you can add these two. If you add these two, minus a and plus 8a will cancel, and plus 2c and minus 2c will cancel. So 4b plus 4b, 8b plus 2d, that is equal to 1. I will take this one as number 10th equation. Right. So using number 9 and number 10, using these two equations, we can find the value of b and d. Right. Now look at this. We can find the value of b and d using these two equations. So from number 10, I can write down 8b plus 2d equal to plus 1. Then 2b from number 9, we can write down 2b plus 2d equal to minus 3. So you can subtract these two. Right. So if you subtract these two, 2d and 2d will cancel. 8b minus 2b, that means 6b, that will be equal to 1 minus 3, that is 4. So b is equal to 2 over 3. Right. B will become 2 over 3. Right. Now we can substitute 2 over 3 in the 9th equation. From 9th equation to b, we can substitute 2 over 3 here plus 2d equal to minus 3. Right. Then we can simplify this. 2d is equal to minus 3 minus 4 over 3. Right. That is equal to, if you simplify this, that is equal to minus 13 over 6. So now we know the value of b and d. Right. So using the same method, we can find the value of a and b. Using the same method, we can find the value of a and b. Right. Sorry, a and c. Right. So we know the value of b and d. So substitute the values of b and d. Substitute the values of b and d in the other 4 equations. Then you can find the value of a and c. Right. So use the same method. And find the value of a and c. So we got the value of b and d. Then we can find the value of a and c using the same method. So a will become minus 7 over 12, and c will become 25 over 12. Right. So now we know the values of all the 4 variables, all the 4 constants. Then we can write down fx. So a is equal to minus 7 over 12 x to the power 3. B will become plus 2 over 3 x square, and c is 25 over 12 x minus d is 13 over 6. Right. So this is the fx function. So using this method, you can find the value of fx function. You just have to find the value of constants a, b, and c, d. So we have found the value of a, b, and c, d. Then this is the value of the fx function. Right. So let's go to another question. Then we can go to past paper questions. Then we can finish this lesson. Right. Okay. Right. Let's go to the another question.